the next option is kind of networking, which is common to our general networking. First important service there is called the domain name DNS, domain name server, which basically provides my IP to the from the domain name. Okay, this is what it is happening here. So there is a user who is accessing google.com via the router. So this is my router, internal router. There it is going to get the IP address. So the IP, it is saying it as 172.217.160.142. Okay, let's say my network got the IP address. So how my router will know that this IP address is sitting in Mumbai or Delhi? Right? That is one of the questions which will comes in, right? So I got an IP address, right? And how I will know that whether this mission is available in the Delhi or Mumbai? The typical thing which happens here is, let's say you see this diagram, right? You have your computer, okay, and you have your gateway, okay, that is your router, okay. From the router, it connects to the ISP, okay. The ISP may have multiple zones in Chennai. Let's say I'm living in the southern part of Chennai, so they may have a separate zone, okay. From there, they will have multiple connections. So it is nothing but a router or a switch, where you will have, in a switch, you will have multiple ports are connected. When the request reaches the switch, router, okay, there it is going to talk about, it doesn't know where exactly this 172 series IP is living. So in all the possible connections it's having, it is going to send out a broadcast message. Like, let's say it may have some direct connection to Mumbai, it may have some direct connection to Bangalore, it may have direct connection to US also. Okay, it will broadcast a message saying that I want to connect to this 172.200.200.200. Okay, so the same way, when the request reaches the Mumbai direct connection, from the Mumbai, it will propagate the information to all the subsequent connections. They may have multiple zones in Mumbai, right? So like that, all the servers are get connected. That is what we call it as internet. Okay, and somehow one switch in which the google.com is connected, okay, that is going to respond saying that I am this 172.200.200. Then the request come back to this one, okay, and from there it goes to Mumbai, and from there it goes to the zone 10, okay, and then it comes to my gateway. Okay, in that case, it updates a table called ARP table. That's called a routing table, right? So this routing table will be used in future. Hereafter, if I want to connect to that, I will directly send out the message to Mumbai. I will not send a broadcast because I will not be wasting my time in sending a broadcast and getting a response. Okay, so this is called the routing concept, in that there will be a table available, and from that it will get connected to it. So this is the routing policy when it reaches the ISP. 0.0.0.0 to 255.255.255.255. This is the maximum IP address you can use in the IPv4. Okay, you can even take your mobile and you can check for your what is your IP address. You can see that it is having any one of the IP within this range. Okay, so initially when this computer network started, they were using IPv4. Okay, so it will be like 2 power. You have somewhere around some 2 million or 3 million IP address. I don't remember the number. Okay, so this is the possible IP address you can have it, but there comes the limitation. For every devices in the world, if I give a IP and connect to the internet, it is not possible for me to manage the network. So what they have did, they have divided this complete range into 5 different classes. They call it as class A, class B, class C, class D, and class E. Okay, class A IP addresses are between 1.0.0.0 to 126.255.255.255. This is the range they have. And in that class, they have defined a specific set as a private IP range, so that that can be used within the private network, and the machines within the network will be able to communicate, but external machines will not be able to communicate, so that the number of public IP address which will be available for the internet will be much higher. Okay, so this is the concept they have brought in. For every class, they have defined the private IP range. Okay, so in the class A, the private IP range is 10.0.0.0 to 10.255.255.255. That's why if you remember, if you see your normal servers, mostly they will fall under this 10 dot series, because the number of IPs are huge in this class, in the private IP address, in this class A private IP address. So data centers tend to use the class A private IP address. Okay, so the next class starts from 128. The complete 127 series is allocated for the loopback purpose. For every machine, you can see that 127.0.0.1 refers to the loopback address. So the complete range is allocated for loopback and diagnostics purpose. So we can ignore that. And the 122 to 191 series, that is 128.0.0.0 to 191.255.255.255 is allocated to class B, and in that they allocated a private IP range starting from 172.16.0.0 to 172.31.255.255. Okay, this is bit lesser than the class A IP range. So class B, which is having a more than class A, oh, sorry, less than class A. Okay, the next range is called the class C, that is 192.10.0.0.0 to 223.255.255.255. Okay, so this is the range they have defined, and the class, the private range in this class is 192.168.0.0 to 192.168.255.255. Okay, so in a home network, mostly this private IP address will be allocated. Even you can check your machine which is connected to the Wi-Fi, you will get an IP address in this range. Very rarely I have seen people using the class B or class C in the home network. Okay, and class D and class E are majorly used for research purpose and some other area. So this is not available for public. Okay, let's not worry about that. So we need to worry about class A, B, and C. Okay, there a specific range is allocated to the private IP. Okay, so in that case, what really happened is, in a data center, if you're having a server, so this will be having a private IP. Let's say I'm having a data center where I have bought a public IP. Let's say, let's call it as 200.200.200. And inside that, I have a private IP of 192.168.1.10 for my web server and 1.20 for my app server. Okay, let's see that area. Okay, in this case, if my web server should go to the internet, it should have a public IP. Then only it will be able to go out. Okay, when the request comes in, it will be coming to the public IP. From there, it will be routed to the web server. Okay, how this is happening, right? That is where the NAT comes into picture, network address translation. So what really happens is, imagine this is a typical scenario where you have a private network, and let's say the machine is having 10.0 and you have a router, and from there it connects to the internet, and it goes to a internet IP called 200.100.10.1. Let's keep that way. Okay, so when the packet, so normally in network, whatever information you are sending, it will be divided into packet. In the packet, you will have a source IP and a destination IP. Okay, when the packet leaves the host, the source IP will be 10.0.0.1 and the destination IP will be the 200.100.10.1. Okay, from the router, let's say the router is having a public IP of 150.150.0.1. There, the address, the source IP address will be translated to 150.150.0.1. So this is also what happens on your home network. In the router where you are connecting, right, via Wi-Fi or something, there the source IP address will be translated to the public IP address of the router. Okay, there it goes to the server. The server reads the request and responded. Okay, there it will say my source IP address is 200 and the destination IP address is 150. Okay, once the packet comes to the router, okay, the router changes the 150 to 10.0.0.1 so that the packet will reach the actual host, which is initiating the transmission. So this concept is called network address translation. This is what really happens when you try to browse google.com or anything, because normally when you are connected to a router, you will be given a private IP. That private IP will be translated to public IP in the router and reaches the target. When the target responds back, the router once again changes the destination IP, public IP to the private IP of the mission. So this is what your router does for you. So this concept is called network address translation. On the high level to understand, you need to understand this NAT helps us to translate the private address to the public address. We have a command called ipconfig. So ipconfig is a command to print the IP addresses allocated to the mission. Sorry, that's Windows command. Ifconfig is for Linux. So if you see that on a default Windows mission, I will have these two. One is the loopback address. I was talking about the 127.0.0.1, right? And I will be having a Ethernet card attached, so which is having a IP address of 172.31.24.251. So this is another layer of NATing which is happening in my Amazon network. So if you see my Amazon, so there will be a VPC. In Amazon, there is a concept called VPC. It's called Virtual Private Cloud. So there, I can see for every VPC, there will be a IP range got allocated. So you can see. So this is the IP range allocated, and any missions coming under the VPC will get IP address from this range. So this is the private IP range. So in my Amazon, I got a 172.31 and this range. You can see that your IP address will be something different, but it will be in the 172.31 series. Okay. So these are only two default network interfaces which are available on the mission. And once you install Docker on the mission, you can see it will install a Docker 0 network interface. That means it is going to create an internal network within the mission, and it will allocate a specific IP range for that. So it will allocate a specific IP in that range, and for every container which is running, it will try to bring it up with the internal network. So if you see that there are two virtual interfaces added, so I will be having two containers running. You see, for two containers, I have two virtual interfaces got created, and these are part of this Docker 0 network. So this is what happens inside the Docker. So when a Docker is installed, it is going to create an internal network. So normally it will be in the 172.17 series. Okay, that is the default configuration of Docker. So it will create a network with the range 172.17.0.0 to 172.17.255.255. It will create the range. Okay, and for every container which is coming on the mission, it is going to allocate one IP. So let's say I have three containers running. One will have a 18 IP, one will have a 19 IP, one will have a 20 IP. Okay. And when the container wants to communicate within each other, so with this internal IP, they will be able to communicate. So if container 1 wants to communicate to container 2, it can use the 172.17.0.19. Okay, but when the container wants to communicate to the external world, that is where this NATing comes into picture, where this address will be translated to this address. Like what we have seen in the general network, right? Your private IP will be translated to public IP, right? The same way, this thing. So this is how the communication works in the Docker. When Docker containers wants to communicate to each other within the machine, they can communicate with the private IP. When it wants to goes to the external network, it gets NATed with the IP address of the machine, and from there it goes to the internet. Okay. So this looks very simple when I run the containers on a single machine, right? But imagine I have the containers running on multiple Docker hosts. So normally when you go for a cluster, you are not going to run all the container on a single machine. You are going to have the container running on the multiple machine. In that case, how things are going to work, right? So I'm just putting a very ideal scenario where I have a container A, right, wants to communicate to a container B running on a different host. Let's say I have two Docker hosts, which is having a 1.10 and another one is having an IP address of 1.11. Okay. So when the container A wants to communicate to the container B, imagine if they are having a different IP, I don't have any problem. So what really happens here is, so there will be a network translation happening, right, between these two. So when the packet comes out, it will look like something like source is and target is, actually this will be this will be the target. Okay, so this will be the concept inside, and when it comes out, so when the packet comes out, it will be transferred like this. So the source will change like this. Okay, and the target, it doesn't know where exactly the 172.17.0.4 is sitting, right? Because it has the routing information for this machine, not for the container, because this machine will never know where exactly the .4. It will try to search for the .4 internally, right? That is where we need to have some external network providers, okay, who can allocate a common IP address for the containers, and they can take care of the communication between them. Okay, that is where the Docker Swarm or Docker Kubernetes comes into picture. They provide a additional network provider which can take care of allocating IP addresses for the containers, and it can manage the communication within the cluster. Okay, so we are going to concentrate more on the Kubernetes. So in Kubernetes, there are multiple network providers available. Okay, so in the left, you see that these are all the list of network providers which are available with Kubernetes, and we are going to work with a couple of them. Okay, so we will see an example of Flannel, Weave, and all those stuff. Okay, so these are pre-configured network providers. In the container to container communication to the to work with multiple Docker hosts, we need a network provider. That is where the Swan or Kubernetes comes into picture. And there they use a concept called overlay network. So it is a network on top of another network. So these two have connectivity. On top of that, I'm going to design an overlay network. That network will manage the IP addresses for the containers. I have two containers running on two machines. So there will be a network provider. Think of it as like a virtual router, which takes care of the communication between these two containers. And they will be allocating a IP address in the specific range. Here, let's stick to on a single machine, how I'm going to communicate from one container to the another container and how I can restrict the communication between two containers. Okay, so this is what we are going to see about that. So let's see the network configuration, whatever we have discussed now. I have shown only the if config. So whenever you install Docker, there are three types of network which will be by default got installed. So to list all the networks which are available on the Docker machine, the command is Docker network ls. So the Docker network ls will list all the networks which are available on the Docker host. So there will be three networks by default installed. One is the bridge network. We already talked about that. Okay, it is going to create a Docker 0 network, and inside that, whenever a container comes in, it is going to allocate an IP address for it. If you want more information about that particular network, you can use the inspect command to get the information. The command is Docker inspect this network name. So the network name is bridge. So if you see that, so the subnet that will be used for it is 172.17.0.0/16. Okay, and the first IP will be the default gateway, and you can see there are two containers running. So it got allocated .2 and .3. These are all the IPs allocated to the containers. So one is my registry container and another one is my Jenkins container. So this is how you can get the information there. And the next network is called a host network. So host network is something when you want your container to react as the machine itself. Okay, this will normally be used in a very restricted networks. In some networks, you will have additional security features called MAC filtering. Okay, so when the packet is coming from that, they will also validate what is the MAC address of the machine, and only if the MAC matches the list which they have it within the network, then only they will allow the communication. So there are more secure network which does all this kind of MAC filtering. In that case, if I try to run the connection as a container, so for every container, there will be a unique MAC address will be generated. You see that for every container, unique MAC address will be generated, and this will not be matching the MAC address of my machine. So there I will have a problem. In that case, I can run a container on the host network. Then the container will be sending the packet as it is getting generated from the actual machine itself. Okay. When I run a container in the host network, I don't need the port mapping. Imagine in Apache, we have done the port mapping, right? When I run the container on a particular, as a host network, I don't need the mapping. So let's see that first, and then we'll come back to the none network. So when I do a Docker PS, okay, I think my 80 port is blocked by Jenkins. Let me stop the Jenkins. Stop Jenkins. Okay. And then let me run the Apache on the host network. So when I run the Docker, just like that, it is by default is going to use the bridge network and bring up the container. If I want the Docker to bring up the container on a specific network, I need to mention that. So let's do that. Docker run -d -rm network. So I need to provide which network I want this to be running. So the network name is called host. Host is the network name, and Apache. Okay. Please note, I'm not giving any port mapping here. When I run this Docker PS, I can see this container is running. If I go back and refresh my public IP, you can see it is hosting the Apache page. So this is the use of a host network. And if you want to run a container on a specific network, you will provide it with -- network option. Okay. So this is how you can run a container on the host network or any network. In the network, if you provide any network name, it will run the container on the specific network. So the next example we are going to see about is called none network, right? So none network is something, when you bring up a container on the none network, no Ethernet adapter will be allocated to that container. That means it will not have any internet connection. Let's see, you want to bring up a container which will just perform some actions within the container and it doesn't need any internet connection. Then you can bring up the container in the none network. So let's see that example. So Docker run -it -work, and let me run the BC box shell. So if I do the if config, you can see it is having only loopback address. No internet interface is getting attached. So if I rerun the command without the none network, I can see it is getting an IP address getting allocated. So this is the use of a none network. So if you run a container on a none network, it will not have any access to the internet. So that's what the use of a none network.